Hello everyone, welcome to my channel Learn Math. In this session we are going to find the values of m and n if x minus 1 and x plus 2 are factors of the polynomial x cube minus mx square plus nx plus 12, and we will use synthetic division to find the values of m and n. So the first step in synthetic division is to write the polynomial p of x in standard form. The given polynomial is already in standard form as there is no power of x missing. We have x cube minus mx square plus nx cube square 1, and the constant terms are in sequence. Step number 2 is to find the values of x from the factors on which we are going to perform the synthetic division. So one factor is x minus 1, we will equate it to 0. So one value of x is 1, and the other factor is x plus 2, we will equate it to 0, and the other value of x is minus 2. Then for performing the synthetic division, we will write the coefficients of the given polynomial. So the coefficient of x cube is 1. The coefficient of x square is minus m. The coefficient of x is n, and the constant term is 12. Then we will draw the synthetic division table. And first we will consider the factor x minus 1, for which the value of x is 1. We will write the first coefficient as it is, which is 1. Now we will multiply the value of x with the first coefficient and write the value under the second coefficient. So 1 multiplied with 1 is 1. Now we will perform summation of the two, which is 1 minus m. Then we will multiply this summation with the value of x, which is 1, and will write the result under the next coefficient. So 1 minus m multiplied with 1 is 1 minus m, and we will perform addition of these two terms, n and 1 minus m. So that is 1 minus m plus n, and we will multiply this result with the value of x, which is 1, and will write the result under the constant term. So 1 multiplied with 1 is 1, minus m multiplied with 1 is minus m, n multiplied with 1 is n. We will perform summation of the two. So 1 added with 12 is 13. So we have 13 minus m plus n. Now the last term is the remainder of the division. As x minus 1 is given to be the factor of this polynomial, which means that this value must equal to 0. So we have found one equation. Equation number 1 will be 13 minus m plus n is equal to 0. As x minus 1 is factor of this polynomial, so the remainder of this division, polynomial divided by this factor, must result in a 0 remainder. Now this equation, which will be formed from a polynomial, now we have divided the polynomial by a factor having power of x is equal to 1, so the next coefficient, which is represented by q of x, will have a power 1 uh, less than the given polynomial by 1, as power of this factor is x raised to the power 1. So the polynomial will be 1x square. Now this is the next coefficient, plus 1 minus m x, and this will be the constant term 1 minus m plus n. Now we can write that the polynomial p of x is the product of the factor which is x minus 1 and to the remaining polynomial which we have represented by q of x. Now when we will perform the division by the second factor, this x minus 1 is not divisible by x plus 2. So q of x will be divided by the second factor. So the next synthetic division will be, we will consider this polynomial and will consider the coefficient of this polynomial, which are 1, 1 minus m, and 1 minus m plus n. We will draw the synthetic division table. And the next factor is x plus 2 is equal to 0, from which the value of x is minus 2. The first coefficient is written as it is, which is 1. Now this one multiplied with minus 2 is minus 2. Multiplication is written under the next coefficient. Now we will perform addition of minus 2 plus 1 minus m. So minus 2 plus 1 is equal to minus 1, and minus m is written as it is. Now this will be multiplied by the value of x. So we have minus 1 multiplied with minus 2 is 2, minus m multiplied with minus 2 is 2m. This is the product of the value of x and this coefficient. Now we will perform addition. So we have 1 plus 2 is equal to 3, minus m plus 2m is plus m, and we have plus n. Now this portion, the last term, is the remainder. According to the given statement, x plus 2 is factor of the polynomial. So when x plus 2 is factor of polynomial, then remainder must be equal to 0. So from here we have got equation number 2, which is 3 plus m plus n is equal to 0. Now we will add equation number 1 in equation number 2. So equation number 1 plus equation number 2 implies that equation number 1 is 13 minus m plus n is equal to 0. Equation number 2 is 3 plus m plus n is equal to 0. We will perform addition. Minus m plus m cancels out. 13 plus 3 is 16. And we have n plus n, 2n is equal to 0, which implies that 2n is equal to minus 18. Divide both sides by 2. 2 ones are 2 and 2 eights are 16, which means that n is equal to minus 8. The value of n is minus 8. Now we will insert the value of n is equal to minus 8 in equation number 2. So equation number 2 implies that 3 plus m plus value of n is minus 8 is equal to 0. So we have 3 plus m minus 8 is equal to 0. 3 minus 8 is 5. So m minus 5 is equal to 0, which implies that m is equal to 5. So the required values are m is equal to 5 and n is equal to 8. Now we can avoid writing the two tables, and we can go for the division in the same table. We have the coefficients 1 minus m n 12. We will draw the synthetic table, and the first factor is x minus 1 is equal to 0. So the value of x is 1. Write the first coefficient as it is, multiply 1 with the result. 1 multiplied with 1 is 1, and write it under the second coefficient. Perform addition. 1 minus m will be the result. Now we will multiply 1 with the result. So 1 multiplied with 1 is 1. 1 multiplied with minus m is minus m. We have written the result here. Now we will perform addition. 1 minus m plus n. Now we will multiply minus 1 minus m plus n with the value of x, and the result will be written under the constant term. So 1 multiplied with 1 is 1, minus m multiplied with 1 is minus m, n multiplied with 1 is n. So addition of the two will be 1 plus 12 is 13 minus m plus n. So this was the first remainder. Now this is the midterm polynomial which we had represented with q of x. So we will directly do the further division. We will write the second factor, which was minus 2, and the first coefficient is written as it is 1. 1 multiplied with minus 2 is minus 2. So minus 2 plus 1 minus m is minus 1 minus m. That is the result of these two. Now we will multiply minus 2 with this term. Now for q of x, this is the constant term. So minus 2 multiplied with minus 1 is 2. Minus 2 multiplied with minus m is plus m. Perform addition of these two, which is 3. Sorry, this is 2m. 3 plus m plus n. So for the first factor, this is the remainder which will be equal to 0, and for the second term or the second factor, this equation will equal to 0. So we can perform the division in a single table instead of going for the two tables as we had done. We have performed the division of p of x by the first factor x minus 1 is equal to 0, and then the intermittent polynomial was represented with q of x, which was then divided by the second factor, because the polynomial p of x will be multiplication of the first factor and the intermediate polynomial q of x. Now x minus 1 isn't divisible by x plus 2, so we will have to divide the intermediate polynomial q of x by the second factor. So we can perform that multiplication in a single table, and from here the first equation, equation number 1, will be 13 minus m plus n is equal to 0, and equation number 2 will be 3 plus m plus n is equal to 0. Now add the two equations, you will find the value of n, and by inserting the value of n in any of the two equations, you will find the value of m. So the value of n is found to be minus 8 and the value of m is equal to 5. So the polynomial in the actual position will be x cube minus 5x square minus 8x plus 12. Now you can verify if the answers we have found are valid or not. So we will take the coefficient of x cube, which is 1, coefficient of x square, which is minus 5, coefficient of x, which is 8, and the constant term 12. We will divide it by 1. So write 1 as it is. 1 multiplied with 1 is 1. Minus 5 plus 1 minus 4. Minus 4 multiplied with 1 is equal to minus 4. Minus 4 plus minus 8 is minus 12. Minus 12 multiplied with 1 is equal to minus 12. So the remainder is equal to 0. Now the second factor, which was minus 2, this intermediate polynomial is divisible by 2, so we will further proceed with finding the other part. So 1 is written as it is 1. Minus 2 multiplied with 1 is minus 2. Minus 2 plus minus 4 is minus 6. Minus 6 multiplied with minus 2 is 12. So the remainder here is 0 and remainder here is 0. So the coefficients we have found are valid. Hopefully this is easy to understand. If you find the video helpful, please like the video, subscribe the channel, and press the bell icon so that you can get notified whenever a math problem is solved. Thank you.